Okay, we're back with part 2. So with this video, we're gonna jump a little more into this project. And you'll notice right here, we just have part 1 of our project. And basically you're gonna put your name right here. You're gonna put your partner's name, obviously here, goes there. What data set are we looking at? We're looking at the drinks data set. And this question is, what are some things, or what are some questions that we'd like to look at? So what might we be interested in to look through? Like, what might we be interested in learning from this data set? So I know just off the bat, like I was looking at this data set and I'm actually curious about how caffeine might be related to calories or maybe possibly sugar in beverages, right? Whether it's coffee or energy drinks or whatever. So I might look at something like this. So I might type a question like, how does sugar relate to caffeine, E-I-N-E, caffeine in different drinks? How does caffeine? I might also look at, I was kind of interested in how does maybe calories or sugar relate to the serving size. And the serving size is actually in weight. I think it's grams. So how does calories and sugars relate to the serving size of different drinks? So just some things that I'm sort of interested in. Now, the great thing about this project is it's really anything that you're interested in looking at. And sometimes, honestly, you might not even know what you're looking for. We might just have to sort of toss out a big net and see if we find anything interesting in this data. Maybe something that stands out to us, maybe a correlation where sort of two things are related to each other that we didn't know about before. So we don't know. We'll have to take a look and see what we can find. So that's part 1. And let's go ahead and move over into part 2. So you'll see right here, it says data analysis work goes here. So for example, we're going to create some new functions. We might do some filtering of our data. We might order it, do a couple different things there. So the very first thing I would like to do is we're going to look at creating a function. And this function in particular is going to be something called a Boolean function. So make a Boolean function here. So if you remember from the previous video, Booleans are true and false values. Booleans are true and false values. And so basically, when we create this function, we're going to look to see if something is true. And of course, if it's not true, it's automatically going to be false. So before I do that, right, let's think about something that we might want to see if something is true or false. Okay, so obviously right here we already have a whole column that has Booleans in it, right? We have is sugar free. Anything else? We don't. But we also have a juice category. We have a type of beverage category. So actually, let's make a function and let's call this function, since the very first thing we see here is juice. Okay. So what I'm going to do is this. And actually, you know what? Before I even do that, what I want to do is I'm actually going to create some variables where I'm actually going to save a couple rows of my table. And the reason I'm going to do that is I'm going to do that so that when I test my function, I know what rows have certain things in them. Now that might sound a little confusing, but we'll will make it a little more clear. So if you look here in my table, the very first row is this beverage here, right? Acai berry drink fortified, it's juice, blah, blah, blah. Okay, so this is the first row. Now in Pyret, and you'll also find this to be the case in most other programming languages, but when you're dealing with something like a table, or sometimes we call them arrays, the very first value is normally going to be at position 0. So this right here is actually row 0. This one here would be row 1, row 2, etc. So what I want to do is I want to save this beverage, and I'm going to call it, I'm just going to call it juice, okay? So I'm going to come over here on the left side, and I'm going to save a row to a variable. And I'm going to show you how to do that. So we're going to call this variable juice, and I'm going to use my single equal sign. And this is what I'm going to do. In order to save a row, I need to first tell Pyret, well, what table is this row in? And of course, it's going to be in our drinks-table. And I use the dot, and sometimes we call this an operator, a dot operator, but the dot is going to allow us to run a specific function on this table. Similar, if you remember, to this function here where I did dot sheet by name, I ran that function on my spreadsheet called drinks spreadsheet. So right here, we're going to say drinks-table, and I'm going to type row-n and open close parentheses. So row-n, this is a function that's going to find a specific row inside of this table. So if I type 0, because if you remember, this acai drink is in row 0, it should save this entire row to this variable. So let's give this a shot. I'm going to hit run. Let's see if it compiles. It does compile, no errors. I'm going to type in the variable juice, hit enter, and you'll see I get just a row back. Cool. Okay, so I know I've got a juice row. Now I'm going to type my drinks table in again, so I can pull up the whole table. And just for testing purposes, let's get something that's not juice. So let's go with this almond milk unsweetened. So this would be row 0, 1, 2. So this is row 2. And let's call this milk. And actually, you know what? I didn't do something that I should have. So in programming, we need to be very, very clear about what our variables actually mean. And so this isn't just juice, this is actually a row. So I'm going to change this variable name to juice row. And I'm going to change this variable name to milk row. And also because computer programmers like to speed things up quite a bit, I'm just going to copy this code from here, Control C, Control V, and just change the value. So this should be row 0, 1, 2. So this almond milk should be row 2. Let's run it, make sure we don't have any errors. Okay, let's type in milk-row, which did not work because I did dash, not underscore. Milk_row. There we go. There's our row. So basically, I'm using these rows, I'm just using these as testing, things to test. Rather than, you'll notice, like, I have to type this whole thing in to get a row. Typing in juice row is probably a little easier to do. Okay, so let's make a Boolean function. So what I'm going to do is I'm just going to cut that, move it down here. Let's make a Boolean function, shall we? Let's do it. So let's say I want to make a function. I'm going to make a function that checks to see if a particular row, the drink in that particular row, is juice or it's not juice. So here's what I'm going to type. The name of my function, and before I type anything, I need to type the keyword fun. Fun, you'll see that it turns bold. Fun tells Pyret that we're making a function. And I want to name my function, and I want to name it very specifically what it does. Okay, and you'll notice I use the word is juice. And the reason I'm saying that is this, if this were a question, if I phrase this like a question, there's really only two answers. Is it juice? Yes or no, right? I'm not asking you what type of beverage it is. It's just is juice or it's not juice. And just like all the other functions we've seen so far, we need to have parentheses and we need a parameter. Now, not all functions need parameters, but for what we're gonna do, we do need a parameter. So what this function is gonna do is it is going to take in a row, okay? It's gonna take in a row from our table because a row represents a single beverage. Okay, so we wanna take in a beverage and we wanna see, for example, if this beverage is juice or this beverage is juice or etc. So I'm gonna type in the word row. Now, to be very clear, row does not mean anything to Pyret. I just made this up. I could put in puppy if I wanted to. It does not matter. The word that goes in here is a placeholder. What matters is what I tell Pyret I'm gonna do with this word. So, and we'll look at that now. So we've got this function called isJuice. It takes in a row as a parameter, and then I put a colon. And the colon is gonna tell Pyret that what comes after it is what the function actually does. So I'm gonna take this row and I'm gonna put these square brackets next to it. Now, what square brackets do, and you gotta be very careful that you don't put parentheses, because parentheses do something different. Parentheses are for parameters with functions. Brackets do something different. So what brackets do is if you have a row, the brackets will let you look at a specific column. In Pyret and in other types of languages, you need two pieces of information, two pieces of info to find a value in a table. You need two pieces of info. The first, you need a row or a row number. And second, you need a column. Okay, just like a map, right? You need like longitude and latitude. You need the same thing if you're trying to find something in a table. So if I, for example, wanted to figure out if this beverage is juice, I first need the row number, which this is row 0, and I also need the column name type, right? If I have the name type and row 0, I can zoom in on this value, which says juice. So this will tell me if it's juice or not. So that's what these brackets do. Brackets let you look at the column. And the way it works is in Pyret is we enter this as a string. We enter the name of the column as a string. Even though we did not make it a column, or we did not make it a string up here, we need to enter it as a string here. And I'm gonna say type. Now remember, same thing goes. If I make that lowercase, Pyret's never gonna find this value because it does not know what lowercase type means. So it's gotta be uppercase. So here's what's gonna happen. This function says isJuice, it takes in a row, and it takes that row and it checks to see if it checks to see what's in this row and in this column. Now, I want to know if this value equals juice. So this is what I'm going to do. I'm going to put a double equal sign. And a double equal sign, this is where we're actually using equals. And what this does is it compares two things. It's saying, does this value right here, which in reality, row and type is actually this value right here. So if I was at row 0 and the column type, this right here that I'm highlighting, this is the same as this string right here that says juice. Okay, it's the exact same thing. So if this value equals juice, if this is true, okay, here's what's going to pop out. Here's what will get output from the function. True will be output from the function, okay? Because the function is this juice? Well, if it's equal to juice, then yes, it is true. It is juice. Otherwise, it'll come back as false. So I'm going to type end, just like I did when I made my table. This just tells Pyret, this is the start of my function, this is the end of my function. Okay, so if that didn't make sense, let's take a look at it here. So I'm going to click run. And remember, I've got to hit, anytime I add something on the left side, I have to hit run. So let's test out our function. So I'm going to type in is-juice. And remember, I saved a juice row over here. Juice-row. Nope, juice_row. Now, when I hit enter, so, one thing I forgot to mention. If you're typing something here, don't hit run. Run is going to reload everything. You got to hit enter or return. So now this is a juice row. So when I hit enter, I should see the word true. Okay, so that worked. Let's test out milk row and see if it works. Now, a fun thing about Pyret, I don't have to type this all again. I can just press the up arrow key. And if I press the up arrow key, I'll see a history of the things I've typed in. So instead of juice row, I'm going to do milk_row, and you'll see it says false. So we know that this function is working. It's checking to see if a particular row in that column, if the value says juice, it's going to be true. Otherwise, it's going to be false. So here's what's really cool about this. And let me demonstrate. So let's pull up our drinks table again. Here's our drinks table. It's got, what, maybe 500 rows, over 500 rows of data. And we've got lots of different types of drinks. Well, let's say I was just interested in working with juice drinks. I can actually use this function right here to make a new table that just contains juice drinks. So what I can do is this. I can say juice_table equals, and what I'm going to do is take my original table called the drinks-table dot, I'm going to use another function called filter. And this function is built into Pyret. And what it does is it takes in a function as a parameter. So for example, I'm going to put in isJuice. Now the interesting thing is that I don't need to do this. I don't need to have a parameter here. I just need to type in the name of the function. And I'm going to hit run. Now you'll notice nothing happens, and nothing happens because I actually need to type in my variable in order to see my new table. So I'm going to say juice-table, oh, it's underscore. Okay, you'll see I have a table, and notice it only has maybe 100 and maybe like 65 or something rows, but you'll notice I've filtered out all of the drinks that are not juice. Because if you remember, this function returns true if the beverage is juice. Everything else is false. So when I filter the table down by this function, it deletes everything that is, or it gets rid of everything that's not juice. Now remember, or don't forget, like you don't have to worry, your drinks table is still there. Drinks table is still there. So if I type it, you'll still see the whole drinks table. I just created a new one with just juice in it. Okay, so we're going to make a second function now. And what this function is going to do is it's going to help us convert values in our table and put those values into a new column. And so let's take a look at our table real quick, drinks-table. And here's what I want to do. I want to Here's the conversion that I was thinking about. So I noticed that the serving description for these different beverages, it varies quite a bit. So we've got like 8 fluid ounces per serving. We have 16 fluid ounces per serving one. I think there's some 12s in there. And so this could potentially cause our data to look different because we're not comparing drinks in the same amount. And I think that it might be helpful to have a column that perhaps shows either calories or fat or protein or carbohydrates or something like that in the same amount of fluid ounces for all the drinks. So I specifically was a little interested in calories. So if you look up at line 42, I said, how does calorie/sugar relate to the serving size? And I'm actually going to change this from weight in grams. I'm going to do fluid ounces and ounces. No, ounces like that. I believe that's how you spell ounces. And so the reason I switched it over to fluid ounces is just drinks or liquids are normally measured like that or in milliliters or something. So I'm going to flip that over to fluid ounces and we will see. Also, I noticed if we did keep that to grams, some of the beverages on this list are not actually liquid. They're like the powder that you mix with water. And I was actually looking at this table and that throws a lot of the data off a lot because there is very little weight to those powdered drinks, but they also have a ton of either caffeine or sugar or something because they're meant to be, only a small amount is meant to be mixed in with a much larger amount of water or something like that. So we're going to stick with fluid ounces and see if we can do this. So the first thing we need to do is figure out how our conversion is going to work. And the best way to do this is to do sort of a ratio. And the way we would do that is, for example, we'll look at this first beverage right here, which is acai berry drink fortified. And we'll see that there's 62 calories in it per 8 fluid ounces. And I actually want to do my conversion and flip everything over to 12 fluid ounces. And the reason I was thinking of doing 12 fluid ounces is that your standard sort of can of soda or of water or whatever is 12 fluid ounces. So I figure that will be a nice, easy visualization for us, a can of beverage. So that's 12 fluid ounces. So the way we would do that is we do something like this. We would say, well, 8 fluid ounces over, was it 62 calories? Over 62 calories is the same as or equal to 12 fluid ounces over X calories, since we don't know how many calories are in 12 fluid ounces. So these should relate because it's the same beverage. So the way we would figure this out is we first have to cross multiply, and you don't have to necessarily know how to do this. This is just math. You probably did this in elementary school, but our formula is going to look on the next step going to look something like this. We'll say it would be like 8x equals 62 times 12, and then to get x by itself, it'd be something like x equals 62 times 12 all over or divided by 8. And so that would allow us to get x by itself. And if we were going to do this for all of the rows in our table, it would look something like this. So our x value, and x is going to be calories, it would be whatever the calories are in the table. So if you look over at the table, it's going to be the value that's in this column. So it's going to be calories times 12 because we're putting it into fluid ounces. And then that will be divided by the serving description in fluid ounces. Serving, and I'll just abbreviate it, serving description in fluid ounces. So this right here should be the formula that will get us to convert and see how many calories there are in 12 fluid ounces. So let's make this in Pyret, and I'll show you how to do this. So first thing, we want to say fun, and that's just telling Pyret that we are making a function. And I'm going to call this cows per 12 flaws. We'll just say Oz like that. So cows per 12 fluid ounces. And this function is going to take in a row, because if you remember, when we're dealing with tables, we're normally looking at the row. We first need the row, and then we can indicate what column to look at to find the values inside the table. So function cows per 12 ounces takes in a row. I do my colon just to tell Pyret this is what the function does. So it takes whatever row we're on, and just like over here, I first need to look at the calories row. So I need to look at the calories row. So if I'm in, for example, row 0, which is acai berry drink, if I'm in row 0 and I am looking at the calories column, this value is actually going to be 62. So this right here that I have highlighted, this actually represents 62 if I'm in row 0. Okay, if I was in row 1, it would represent 23, etc. So I'm going to take that value and multiply it by 12. And if you remember, this does need to be in parentheses. And because of order of operations, it should do it automatically, but I just do this to be on the safe side. So row and calories, that value times 12, and then I'm going to divide it by the serving description. So I'll come over here and calculate, or I'll just copy the name of that column so I don't make any spelling errors. That's going to be row that. Okay. And then of course, to end my function, I just need to type end. And I'm just going to run my code, just see if there are any errors. There does not look like there are any errors. So let's test out this function, cows per 12 ounces. And if you remember, I declared a couple rows up here. I saved them as variables to make it easy for me. So I'm just going to type in juice row, hit enter. It's saying 93 calories. Let's see if that sort of matches up. Drinks dash table. Let's see how many calories. So we're looking at 62 there. That sounds just about right. If we went from 8 fluid ounces, 12 fluid ounces, that is looking like it's working. So another way I could test it is row 2 is a milks row. So 0, 1, 2. Yeah, this one, the milk row is actually 16 ounces and the calories say 15. So if I run this function on the milk row, it should be a smaller number than what's in the table. So it's saying 11.25 calories. If I look at row 2, yep, that looks about right. So it was originally 15 calories for 16 fluid ounces. We dropped it to 12, so the calories dropped down a little bit. So that looks good. That looks like it's working. Now, okay, that's great. So that function is a conversion function, which is awesome. But now, how do we actually convert for the entire table, and how do we add a new column on? Well, this is where we have a built-in function, and this is part of Pyret. And what it does is it builds a new column using a function. And here's how we do it. So first thing I'm going to do is I'm going to create a new table, and I'm just going to call this drinks dash table 2. And I'm going to say that equals, and just remember one equal sign because I'm creating a variable. And I'm going to take my original drinks table, and I'm going to do dot build dash column. And build column is a function. It's built into Pyret. And the parameter that this function takes is another function. So the function we're going to put into it is cows dash per dash 12 OZ. Okay, hit enter. All right, let's run this. Now we shouldn't see anything, or we should, because, oh, And I actually forgot this takes 2 parameters. It needs to know what I want to name the column. So I want to name the column, and let me look what the other columns are called. So they're all sort of underscored. Let's just say something like calories per 12 underscore fluid underscore ounces. So you'll see here I just created a string and I called it calories per 12 fluid ounces, and I'm using this function. These 2 things do not match at all. This is just the name of the column. This could be anything, right? I could put, you know, apple here, and it would just make a column called apple. Okay, so we'll just call it that, and let's hit run. See if we get any errors. Nope. Okay, you'll notice the table didn't load because I actually need to type in this variable. So I'll say drinks dash table2, hit enter, and cool. So over here you will see we have a new column, and it's going to have the calories per 12 fluid ounces. So what's cool about that is now we can at least look at calories with the same amount of beverage, which should be a little helpful. So what we'll do, we'll stop there. And in this video, we looked at a couple different functions, how to make them, specifically a Boolean function. We also learned how to create a function that does conversions. And we also learned a little bit about just the built-in functions in Pyret, and also about variables, right? We saved rows to a variable. We also saved tables to a variable. So we learned a little bit about that as well. The next video, what we'll do is we'll jump into some visualization and start looking at a couple different types of graphs that you can make in Pyret. And one of the great things about graphs is that it's very hard to see what's going on when you're looking at a big table like this. You can't really see what's happening. You don't really see trends. You don't see maybe correlation between different types of items in the table. So that's where the visualization comes in, and graphs can be really helpful for that. So next video, that's what we'll look at. All right, see you next time.